Welcome and hello. This is a video exercise using the HEC RAS controller. In this exercise, we are going to be updating steady flows using a user form. So what you see on the screen is HEC RAS. We're going to start from the very beginning. We're going to be building a HEC RAS model and then using the VBA to build a form, update steady flows, run the model, and view the results. So go File and New Project. Navigate to where you want to save that project. For me, it'll be Project like RAS. Then I'm going to call this project. You can call your project whatever you want. We're going to be using US customary units. And then down here in the geometric data editor, go edit geometric data. That's how to open up this window. River reach, single left click at the upstream end of your reach. Make as many clicks as you want to define the alignment, and then double click at the downstream end of your reach. I'm going to keep things super simple here. So river A and reach 1 is what I'll call this specific reach. Next, open up the cross-section data editor. Let's add a cross-section. Let's put this first one at the downstream end. So we'll say river station 0. And then for the station elevation data, I have some numbers prepared just to save to my clipboard. Apply data. Boom. Here's what that cross-section looks like. Vertical axis here is exaggerated, so it doesn't look quite like that to scale. All right, some of the downstream distances will be 0 for the left overbank and main channel, and right overbank Manning's numbers are right there. And then the left bank station is going to be 40 and right bank station will be 100. Okay, apply data. I'm going to go options, copy the current cross section. So I'm going to go ahead and put the upstream cross section at river station 1000. So click OK. Boom, here's a copy. Here was the first one, river station 0, and then this is a duplicate, river station 1000. So let me just update the downstream distance. We'll leave everything else here the same, and then let's increase the elevation values of all of our points by 1 foot. So options, adjust elevation, type in a 1. Okay, let's see. I'm going to add a few intermediate cross sections as well, just to make it look a little bit more normal within a reach, and I'll say every 200 feet, interpolate, close. That's all we need to do for our geometry. So we'll go File, Save Data. I'll just call this Base. Now let's go ahead and define some steady flow data. I'm going to click on Edit, Steady Flow Data, and I'm going to start off with 3 flow profiles. Click on Boundary Conditions. For the downstream boundary condition, I'll go with normal depth. 0.001 is our slope, and then click OK. Now for our 3 flow profiles, I'm just going to start us off at 1, 2, and 3. This is something that we're going to be able to change in our user interface. Actually, I should probably set them to something a little bit higher. So let's just go with 100, 500, 1200. Okay. Let's go ahead and save that. So file, save flow data. Again, I'll just call this base. We're only going to have 1 flow file. We're only going to have 1 geometry file. So we can keep things simple. Let's go ahead and run it just right here in the GUI. Take a look at our results and then get started with our user form and the VBA code to connect everything together with the RAS controller, of course. So run and steady flow analysis. This most likely will be subcritical flow because the slope is only 0.1%. We have our geometry and our flow file all set and ready to go. So file, save plan. I'll call this base again. And then short ID. Base is fine. Compute. Okay, so that ran. Let's take a quick peek at the cross-section results. So here's that, PF1. I'm only showing 1 flow profile, so let me just go to options, add all 3, and boom, here are the water surface elevation, river station 1000. Let's go ahead and look at the river station 0 cross-section profiles. So profile 1, 2, and 3 are shown on the plot right here, and those are associated with our 3 different flow rates of 100, 500, and 1200. So that's how to manually do what we're going to automate using the HEC RAS controller and some code to connect the form to the HEC RAS and the input and the plot. So anyway, lots to do still. I'm going to open up my Excel file here, which I'm calling controller.xlsm. If you're going to be writing macros, you need to make sure to So file and then save your workbook as a .xlsm, which is a macro enabled workbook. So just a FYI there. Let's start by going to the developer tab and then Visual Basic. And I'm going to insert a user form. Okay, so here's my user form. I'm going to make it a little bit larger because I can always make it smaller later. I'm going to start by adding a label and a text box and a spinner to identify the number of flow profiles we want. So here's the label tool. I'll just go ahead and put that right there. It's called label 1. Move this up here. The name is not too important for this particular label, but the caption is, I'm going to call it profiles and then tab off. This is going to be a label for the number of profiles. I'm going to add a text box right here. So just drag the text box onto the form. It's only it needs to be 1 character wide for 1, 2, or 3. So there's that. And then I also want a spin button it's called. So let's put that right there. This is going to allow us to change the number of profiles between 1 and 2 and 3. Okay, I need to change the text box name to something a little bit better than just whatever the default is here. So text box 1, we change that to profile count. And then the spinner, I'm going to change the name of that as well. So I'll click on the spinner element. And then instead of spin button 1, I'll call it profile count spin. Now, if I wanted to set a maximum and minimum to the values associated with the spinner, if that's the text box, which we'll tie together in a little bit later step. Then select the spinner, and then scroll down here to max and min. So right now it says max is 100. We want that to be 3. The min is going to be 1. So set that to 1. As you can tell, there's a lot of other properties available to us. So we're not going to deal with that too much. In fact, I'm actually going to set the maximum, minimum, and initial value of the spinner and the text box programmatically. So let's go ahead and do that right now. You can open up the user form by just going right click on code. So now the code window is the user form. So any reference to ME would refer to the user form itself, which is currently called user form 1. What I'm going to do next is paste in a couple subroutines. So this first subroutine is going to operate on the user form object, and it's going to get triggered or invoked at the time that that object is initialized. What we're doing here is just what it says in the comment, setting the profile count and the spinner. So right here is the spinner element. We're setting the minimum, maximum, the amount we're changing it by, and the initial value. And then right here, we're setting the profile count value, that's the text box, to the value of the spinner, which is 1, which is right there. And then the second subroutine, we're going to connect the profile spinner to the text box. So whenever the spinner changes, so we can get the object here, underscore the event, then we're going to update the text box with the updated value in the spinner, which again can only be 1 through 3 on an integer step. All right, let's go ahead and see if that works. So baby steps, I'm going to save it and then right click on the user form. I'm going to select view object and then click on run. So here is our form. It's running and the number of profiles is currently 1. That's what we started it as. That's correct. Let's go ahead and arrow up 2 and then arrow up again 3 and then arrow up again and stick at 3. So it looks like the minimum and the maximum constraint works. And I realize this is pretty ugly. It's not very appealing to the eye. So we'll just forge ahead and just realize that this is not a particularly well polished user interface. You can click add a button to cancel or close, or you can just click on this button up here to close. It'll bring us back to our code view. What is this called? Object view. Okay, so object view is where I want to stay because next we're going to be adding a couple text boxes, 3 text boxes for flow rates. Let me try to move this label a little bit further down. Okay. All right. So let's go with another label, and then just click on the form. This says label 2, but I'm going to change that caption here to flow rates. So flow rates, resize that text box a little bit there, right about there. Okay. Now let's add 3 more text boxes for us to type in the flow rates that we want to be using for our HEC RAS to be updating that steady flow file. Again, I'm going to click on the text box tool, and then I'll just boom right there. And this is a little bit too wide, so that looks good. In fact, I'm just going to make a copy. So right click and copy because the size is pretty good. Paste. And then let's just paste one more. Boom. Right. So one thing you can do is highlight all of these and then go right click, align, and then align the tops. Okay. So that's one way to kind of get things looking nice. So we're going to have profile 1, profile 2, and profile 3. So what I need to do next is add those particular names to the 3 text boxes that we just put in. So I'll click on the first one, come over here to name. Instead of text box 1, it'll be called flow 1. The second one, click on, and then go over to the names in the properties box, flow 2. And then finally, flow 3 is right here. So let's get that updated, and boom. Now, what I want to do next is I only want to display the first flow rate. I want to actually hide flow rates 2 and 3 on the initialization when this form initially launches. So to do that, there's a couple ways to do it. I could just click on both of these elements or just one at a time. And then down here in the properties box towards the bottom, there should be a visible property. It says true by default, but I can change that to false. I'm going to actually do this step programmatically as well. So I'm going to go right click on the user form, view code, and then within this user form initialize subroutine, I'm going to make myself some more room here and then paste in this right here. What I'm doing is just like I described flow 2 and flow 3, I'm setting the visible property to false. However, we want that to become visible if we change the spinner to a number that is 2 or 3. So down here in the profile count spinner change subroutine, I'm going to add code that does exactly that. So using this select case code construct, if the spinner is 1, then we're going to basically have it the same as initialized, only flow 1 will be visible. If it's 2, then text box 2 becomes visible, and then if 3, then they're all visible. So let's go ahead and test that. So we're just kind of testing things as we go. So let's save that. User form, right click, view objects, and then let's run it. Okay. So this looks good. It starts us off with a 1, and we're also only seeing one flow rate text box. If I go with the spinner up, boom, the second one appears, spinner up again, the third one appears, and then okay, good. And then arrow down. All right, very nice. We are ready to continue on. I'm going to add a button to compute. So here is the button right here, and then we'll just drag a button shape. Okay. I'm going to name this button compute, or I guess I could say update and compute, but calling it compute would also include updating the flows. So with the button selected, the name is, let's call it BTN compute, and then the caption, which is what I was just talking about, just compute will be fine. All right. So let's go right click and then view code. Now, when you do it that way, it's going to automatically set you up with a subroutine with the specific object, the name of the object underscore, and then the event. Okay. So I'm going to paste in what I have prepared for the compute button. And what I pasted in was right here. So that is that. One more thing I do need to include is the open project subroutine because I'm calling it from within this BTN subroutine. All right, so first thing, we're going to create a HEC-RAS controller object called con, and then I'm going to call this open project subroutine. It's going to pass con by reference, and then open up my project. So far, so good. Next, what I'm doing right here is this is the flow rates, and I just realized there was one more thing I need to add to this. So one moment. Okay, that right there is also something I realized is necessary. Okay, so what I'm doing is getting the profile count, that's 1, 2, or 3 from the user interface, and then I am creating a flow rates array that's data type single, and I'm going to make it 3. So even if we only have 1 or 2 flow rates, I'm still going to initialize this array at 3, and then I'm going to populate it with the actual values. So that's what's happening in these lines right here. If there's less than 3, I'm just going to make it 1. I'm just going to set the flow rate at 1 because if it's 0 or even a negative number, I'm going to get an error message. And to be honest, in HEC-RAS, I haven't been able to figure out how to programmatically through VBA and the HEC-RAS controller change this number right here. So anyway, this is going to be fixed at 3. And if it happens to we only happen to enter 1 or 2 flow rates in a form, then I'm just going to set the other profiles to just one CFS flow. So that's not a perfect solution. I'm not too wild about that, but that's what we're going with. All right. So we got the flow rates array. And then right here, this is how we're going to update the steady flow for River Station 1000. See, it's River A, Reach 1, River Station 1000. And then we're going to send it this flow rates array, which is data type single. Also, something missing from this subroutine is actually running the computation. So that's what we're doing right here. I'm calling this compute underscore current plan. And then finally, we're going to save the project and close RAS and then just have a message box that says done. All right, so fairly straightforward. Let's go ahead and see if that works. I'm going to save what we have and then right click, view object, and then run subroutine. Okay, 1 second. User defined type. Ah, so I do need to include the HEC-RAS controller reference details, right? So to do that, go up to Tools, References, and then scroll down to HEC-RAS. So HEC, here it is. I'm using version 6, so that's that one. Checkbox on, and okay. I think that was the only error we encountered. Let's see what happens when we try this again. So view the object and then run. Okay. So we're ready to rock and roll. Let's go ahead and see what happens here. So let's go with how about two profiles? The first profile will be 560 CFS. I guess I could have included units, but let's just make sure to get it working first. And then the second one will be how about 1480 CFS. All right. So fingers crossed. Click on compute. And I think it ran. I probably should have closed the heck has already. It says done right here in the message box, so that is auspicious. Let's go ahead and close that and then see what results we have. I'm going to just open up HEC-RAS. Actually, you know what? Let me go ahead and check for background processes because I don't want to have it open multiple times. Okay, I don't see it here in the task manager. Let's go ahead and manually open this up just the old-fashioned way. I'm going to navigate to my project and open. Okay, I'm going to open up the steady flow data. Very nice. So what I like to see here is the 560 and the 1480. And then PF3 is set to just 1 CFS, which is kind of my null case. Let's check out some results. I'll click on the cross-section plot, and very nice. PF1 is 560, and this was the, 1480 or whatever I said. And then PF3 is in the mix. It's right down here at 1 CFS. All right, so the only other thing I want to do in this exercise is to bring up this plot automatically and also bring up the steady flow data just so I can check to make sure that it worked. Now, we already checked it manually, but it was a little bit of a hassle having to click 10 or 12 times and move the mouse 10 or 12 times when one single button click can solve all those problems, especially if we're going to be running multiple iterations over and over. So let's go ahead and close everything up here in the user interface. Here is our form. Let's add another button right here that's next to compute. And then let's call this show results. That'll be the caption. So come over here to the properties and then boom, show results. For the name, let's call it BTN Open RAS. So it's going to open RAS. It's going to do a few things here. I should probably spell it right. And all right, so right click. Let's view the code. Here is the code for that button. And then this is what I pasted in right here. So as before, we're going to create a HEC-RAS controller object. We're going to open the project. We're also going to show the interface this time. And then what this line of code does is it's going to open the steady flow data editor dialog box. And then what we're doing here is opening up the cross section for River A, Reach 1, specifically at cross section River Station 0. So that's what's happening here. Let's go ahead and do a few more tests, both with different flow rates, but also utilizing this new button to open RAS and view the results. So let's save what we have. We're going to go user form, right click, view the object, run. Okay. So here we are. Let's go ahead and just try one flow rate. So what should we try? How about 888? I'll click on compute. Wait a moment. We should get the done dialog box. Okay, message box, there it is. Now let's try out this show results button. So boom. So it opened up. Beautiful. So here's the flows, 888, 1 and 1. And then here's our plot for the cross section. And it should be PF1. Yeah, so this is the water surface elevation for our flow rate of 880 CFS. We also happen to have PF2 and PF3. I haven't figured out how to hide that yet, but so far so good. All right, let's do another test. Let's get over the overbank with a larger flow rate, like maybe 2000 or 3000. Let's do a test with all three flow profiles. So let's close that. Let's close that. We're actually still running the program. See, the user form isn't closed yet, so that's cool. Let's go ahead and increase to 3 profiles now. In addition to 888, actually, let's just go ahead and change that just so it's changed a little bit. How about 700? And then how about 2000, 3300? Okay. And compute. Okay, that took a few seconds, maybe 5 seconds. There's done. Click OK. Now let's click on Show Results. Right. So we're opening up RAS. Here are the 3 flow rates, 700, 2000, 3300. We can close that. And then boom, here is the cross-section plot, 700, 2000, and PF3 is, what did I say? Let me open that up again, 3300. All right. Something isn't quite right here. I can't imagine that's 700 and that's 2000. I think I might be saving this in the wrong spot. Let me close things up. Let me close that and then just check my code real quick. So view code, see where's my main compute routine? Yes. So what I'm doing is I'm actually saving it um, after I run the compute. Where I'm changing the flow rates are right here. So I'm going to actually save it right here. Save RAS. Boom. Okay, let's go ahead and run the same numbers and see what the results look like. Open up the user form, view object, and then run. In fact, we can look at the results in a different table, such as the profile summary table that would show us the flow rates. So let's go to view and then profile summary table. Oh, sure enough, it does have 700, 2000, and 3300. Okay, let's do one more test just for fun. I need to close RAS. Let's go with 3 flow profiles. And then how about 222, 333, and then how about 4000? So something big and compute. Okay, here's our done message. And then let's check out the results. Here, let's double check those are the correct numbers for the flow rate. And then boom, here are the correct water surface profiles for River Station 0, PF1, PF2, and PF3. That's it for this exercise. We did a number of things. We built out a model in HEC RAS, and then after that, we built a user form and the code behind it to run HEC RAS based on our input data and also show the results.